Hello my dear, this is Ujjwal Kumar Sen. Again I am back with another question, and this is the question of you can see steady flow energy equation. This is a question of SFEE, and this question has been asked, if I am not wrong, in 2000 gate in gate 2012. 2 marks each. This is for 2 marks, and this question is also for 2 marks. Now you can understand how important is this type of question for anyone who wanted to appear for GATE 2016 and so on, 2017, 18 and all those examination. And if you're also preparing for any other examination, then this problem, this topic is most important. And if your syllabus is having thermodynamics, well, so I am going to share with you how you can solve question for steady flow energy equation. So let's read the question and try to draw a diagram. That's why I can understand what is going on in this question. I'll tell you the basic concept. I'll also share with you where you are going to make mistake in this type of question. That's why you will not repeat those mistakes while solving questions in the competitive examination. Okay, so let's move forward. In this question we have air enters an adiabatic nozzle. So this is a question of nozzle. What we got from till now, this is the question of nozzle at 300 kilopascal. That's okay, and 500 Kelvin. So let me draw a nozzle. I can draw like this also, and entering is here, exit is here. So how many pascals is there? 300 kilopascal, and this I'll assume it as P1 is equal to 300 kilopascal, and then temperature is 500 Kelvin. So I'll assume temperature 1, inlet temperature would be 500 Kelvin, as well as velocity is given Vy equal to 10 meter per second. Now what we have, it leaves the nozzle at 100 kilopascal. So from the question we can get it is losing pressure by 200 kilopascal because it is passing through, the air is passing through this nozzle. That's why its pressure is decreasing. Why? Because its velocity is increasing, because the velocity of 180 meter per second. Previously it was how much? Let me show you. Previously it was only 10 meter per second, but right now V2 is equal to, you can see here, 180 meter per second. Now what we have, inlet area. So A1 is equal to 80 centimeter square. We have to look at this because this is in centimeter. We have to take care about this thing. Now the specific heat of air Cp is equal to 1008 joule per kg Kelvin. This is also one of the basic thing. If you are solving question of thermodynamics, you must know specific heat of air, specific at constant pressure, constant value, as well as specific heat of water. Well, so let's read what we have to find out. Till now what we got what we have. Now we are going to see what we have to find out. So before solving any numerical problems, we have to think what we have given first. Then we'll go for what we have to find out. So here in this question, we have to find out the exit temperature of the air. So T2 is equal to what? We have to find out that only. If anyhow we can find out temperature, then we also find out area. And another thing we have to find out A2. How much area of this exit side of the nozzle, and that also in centimeter square. Well, in GATE examination we have online calculator. Right now we cannot we cannot carry calculator like this one I have, so I'm going to show you how I am using it, but it's not useful right these days, in these days, because in these days we are using scientific calculator, online scientific calculator. So okay, by the way, I don't have right now online scientific calculator because I am not sitting in front of my PC. I have my camera and all these things for you. Okay, I hope I can show you all those things, and you will understand how to solve such type of questions. Okay, let's move forward. So what we are going to do, we are studying about steady flow energy equation. So what we have a topic, that is steady flow energy equation. What is that? Let me write here. So according to steady flow energy equation, SFEE, what we have, H1 plus kinetic energy 1 plus potential energy 1 plus Q is equal to H2, this is equal to, plus kinetic energy 2 plus potential energy 2 plus W. So this is because a case of adiabatic, so all these terms tends to 0. All these terms tends to, we are going to consider all these terms as 0. So what we have remaining right now, H1 plus kinetic energy 1 is equal to H2 plus kinetic energy 2. Now we know the formula of kinetic energy. Let me show that thing only. Okay, now what we have, kinetic energy. We have this equation, kinetic energy is equal to what? Kinetic energy equal to half mv square. We are not considering here mass because we are taking m is equal to 1. We are not thinking about that because we have given velocity. So we are dealing with the velocity in this case. So what we can write here, h1 plus half, because inlet is, we have taken inlet velocity as v1, you can see here, that's why half v1 square is equal to h2 plus half v2 square. As simple as that. So what we are going to write right now, let me show. Okay, so h1 is equal to half v1 square is equal to h2 plus half v2 square. Alright, so we know again h is equal to cpt. So we can write in the case of h1 is equal to cpt1 plus half v1 square, h2 is equal to cpt2 plus half v2 square. Now we know cp is equal to 1008, t1 we know 500 Kelvin plus half v1 is equal to 10 square, cp we know 1008 into t2 and then half into 180 square. If you will do calculation, I did a little bit, let me show you again. If I will calculate this, I don't want to take time to calculate because I did already. If I will calculate here, if you calculate these things, we can easily find out the value of this this term T2. So T2 is equal to what we have, T2 is equal to 484 Kelvin after calculating. So if I will see option, then which option is right? Option C is right. So in this way we can solve the question 1. Well, it took around 8 minutes 23 seconds because with time or with step by step I was telling you, if you will practice a lot, you can solve this question within 2 minutes or 1 minute. It is really easy to solve. Well, let's move to the next question. What we have, exit area of the nozzle in centimeter square. Okay, here you are going to make lot of mistake and you are going to get also answer among out of these 4 because those selected option, 4 options, they also calculate that way. They also calculated that way to find out answer. Which type of way we have to solve the question? Well, I am going to tell you what we know. According to continuity, we are going to use continuity equation here. We know A1 V1 is equal to A2 V2. Now we have A1 is equal to 80, V1 is equal to 10. Doesn't matter it is meter per second, it is centimeter square. And A2 into V2 is equal to 180 meter per second. Meter per cancel. So this is centimeter square. That means A2 is equal to also remaining in centimeter square. Now value is equal to what? 800 by 180. Now what I am going to get, I am just going to show you. I hope you are getting 800 divided by 180 is equal to 4.44. If you will see option, then we have one. But this is not a right approach to solve the question. This is a wrong formula you are going to implement in this topic. I don't want that. That's why I am using or I am sharing with you that thing. So this is not a good approach. This is not the right answer. So maybe you are thinking which way we can solve the question. That's why we can find out or we can get the right answer. Well, don't worry, I'm here to help you. That's why you can reach to the right answer. Okay, let's move forward. So according to in case of steady flow energy equation, if you were taking a concept or taking a case of nozzle, in that case we have an equation that is A1 V1 rho 1 is equal to A2 V2 and rho 2. And here we have to use another formula, that is ideal gas law. PV is equal to MRT. Why I am telling you to use this formula? Because we know A1, we know V1, we know V2, we don't know, we need to find out A2, and we don't know about rho 2 and rho 1. So what method or what option we have to find out rho 1 and rho 2? That's why finally we can find out A2. That exactly I am going to share with you. So here what we can do, this is rho 1 is density. Density is equal to mass upon volume. We know density is equal to mass upon volume. So if I will transfer this volume to this here, so what we got, P is equal to M by V RT. So M by V, what? Density. So density is equal to P by RT. So finally what we can write here, I am going to show you in the next page. Just wait, let me arrange little bit. Okay, now it is well arranged. Now I can show you what is happening here. Okay, yeah, now so what we can write in the place, here what we can write, in this equation I am going to write. Okay, so yeah, now A1, okay, into V1. Okay, now P1 is equal to what? V1 by PV. So P1 is equal, okay, no, density equal to P upon RT. Okay, now P1 by RT, RT1 is equal to A2 into V2, P2 by RT2. Simple. Now I don't want that, that's why I'm moving. Okay, now we know A is equal to what? A is equal to 80, V is equal to 10, P is equal to 300, T1 is equal to what? T1 is equal to 500. R is cancelled. Now we don't know A2 because we need to find out this. We required. So 180 is here, P2 is 100, and then T2 is equal to, we have just calculated the value of T2, that is how much? 484. Now what I'm going to do, I'm not going to change its unit because it's matching all those units. All unit be cancelled and finally remaining in centimeter square, and the value is equal to A2. So what I'm going to do, I'm just going to calculate this and going to show you. Okay, now what we are going to solve, this portion first. 80, now I hope you can see, yes, you can see, into 10 into 300. Okay, 80 into 10 into 300 is equal to this much, and then divided by 500. What we got here? 480. Now we are going to calculate this one. This will come up upside. So what we got? We got 480 into 484 is equal to this much, divided by 180 into 100. We got how much? Now you can see the answer here. I just find out after calculation. This is how much? 12.906. So finally A2 is equal to 12.906 centimeter square. Now we'll look at the options over here. I got this the first page, this. So the answer for the second question is option D, 12.9 centimeter square. So this is the approach. This is the real approach to solve any question in GATE. But for solving question in GATE, you have to have basic concept. Without basic concept, you cannot solve the question right way. So try to first read theory. then solve few questions, previous year questions, and if you are not understanding any question in GATE in any topic, then let me know. I will try to make a video and I will help you to crack GATE with very good marks. Well, thanks for watching. Hope to see you again in my next video. Bye bye.